Hi there! Welcome to Tech Talks. Today, we'll be exploring SOLID principles, a set of 5 design guidelines in object-oriented programming that help us write cleaner, more maintainable, and scalable code. SOLID is an acronym that represents a set of 5 design principles that help create well-structured, maintainable, and flexible software. These principles were introduced by Robert C. Martin and are widely used in object-oriented programming to guide the design of software systems. Let's break down each principle with simple examples in Swift iOS. First, Single Responsibility Principle, or SRP. It states that a class should have only one reason to change, meaning it should have only one job or responsibility. Let's look at a quick example. Here's a user class. Now, what's the problem here? This single class is doing 2 jobs. It's saving to the database, and it's sending emails. If database logic changes, the class changes. If email logic changes, again, the class changes. That's a violation of SRP. Here's the corrected version. Now, responsibilities are clear. First, user database handles database operations. Second, email service handles email logic. Each class has a single responsibility, making the code cleaner, easier to maintain, and much more testable. Second, open-closed principle, or OCP. It states that software entities should be open for extension but closed for modification. Let's look at a simple case with shapes. The shape class violates OCP because it needs modification whenever a new shape is added. Instead, make it open for extension. Here's how we fix it using extension. Now, the calculate area doesn't care whether it's a rectangle, circle, or any new shape. We can extend the system with new shapes without modifying the existing class. That's the power of the open-closed principle. Keep your code open for extension, closed for modification. Third, Liskov substitution principle, or LSP. This principle states that objects of a superclass should be replaceable with objects of its subclasses without affecting the correctness of the program. Let's consider a simple bird class. Here, we tried to model all birds under one parent class. But the moment we substitute ostrich for a bird and call fly, the program breaks. That violates LSP. So how do we fix this? By designing more accurate abstractions. Now, sparrow implements bird, and ostrich doesn't pretend it can fly. Any code expecting a bird will work with all flying birds, and ostriches remain valid birds without breaking anything. Fourth, Interface Segregation Principle, or ISP. This principle suggests that a class should not be forced to implement interfaces it doesn't use. It's better to have smaller, specific interfaces. Let's imagine we design a machine protocol like this. Now, if we have a printer class, the problem? Our printer is forced to implement methods it doesn't need, violating ISP. Here's how we fix it using smaller protocols. Now, classes only conform to what they need. Here, laser printer only depends on the printer protocol, and office scanner depends on the scanner protocol. No unnecessary methods, no broken contracts. That's ISP. So remember, keep your interfaces lean and focused. Clients should never be forced to implement what they don't use. Fifth, Dependency Inversion Principle, or DIP. High-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. Let's see what happens if we don't follow DIP. Here, switch is tightly coupled to light bulb. What if we want to switch on a fan or heater? we'd have to rewrite the switch class. That's a violation of DIP. Let's fix it by introducing a protocol switchable. Now, lightbulb just conforms to switchable. And the switch class depends on the abstraction, not the concrete class. Now we can add new devices easily. Here, switch doesn't care what it's turning on or off. It just relies on the switchable abstraction. That's DIP in action. So remember, with dependency inversion, always depend on abstractions, not concrete classes. This keeps your code flexible, reusable, and future-proof. If you enjoyed this video and found it helpful, don't forget to like, subscribe, and hit the notification